Hey everybody, Mr. Jones here, and we are going to be translating some verbal expressions. Okay, this can be a tricky one for kids. We're going to do it. You don't see any of them on the board because these are easier to do on a worksheet. Okay, so I'm going to jump into these using my old document camera, aka my phone, just propped up with some stuff. Okay, so here we go. Okay, guys, so here we go. We're going to start our verbal expressions. So what we're doing here is we're translating, right? And if you're a person who knows multiple languages, translating is something you know how to do very well, right? Translate from the language you're comfortable with to the language that you're learning, right? And that's what we're doing here, except we're going from the English language, right? These phrases that are said in English to like a math language or saying them algebraically, okay? And so we're going to do a few of these. We're going to do translating them going from English to math, and then on the back we have these where we're doing the opposite. We're given the math statement, and we have to figure out a way to say that in the English language. Okay, so um, just a few things. Okay, so what I give to my students is this little helpful bank up here, and I explain these, right? And just like when you're learning a new language, you have to kind of be given a key to help you there too. Okay, so there's different phrases that kind of refer to a math operation, right? So addition, subtraction, multiplication, division are our four basic math operations, right? And so there's going to be some phrases that kind of refer to each of these. So, like for example, if I said eight more than a number, okay? Well, first off, let's talk about a number, right? You see that if you look over this page, you see a lot of these say a number, a number, a number, a number, right? Why does it say that? Well, in math, again, and especially in algebra, right? Sometimes we know what the number is. Like if it says, we know the number is eight, it'll say eight. But when it says a number, right, that means it's an unknown amount, right? We don't know how much it is, right? If we did, it would say the actual digit, the actual number, instead of saying the words a number. So that when you see the words a number, that means that's going to be an X, right? We don't, that's an unknown amount. So we put an X there. And so what I did with these two is these are all different ways of saying the same thing, right? All of these addition ones could be written, they're all going to look the same, right? Actually, I have it here. These are all ways of saying the phrase X plus 8, right? So all of these words are ones that refer to addition, okay? And so it's helpful to just have that bank there. So when you see them and you're given problems like that, you can refer to that, especially as you're first learning it. That's super helpful. Subtraction, difference or decreased by or less than a number or say subtracted from a number, that's pretty obvious. But you're right, all of these are a way of saying the unknown number. I use R here. I guess let's stick with that. R minus 6. Okay. Now multiplication. Multiplication. Okay. Again, all of these, same thing. They're a way of different ways of saying the same thing in math. Okay. So twice a number. Okay. Twice. That's a helpful one to just remember. Twice something means two times, or double that amount is another way of saying it. The product. Product is that word that means multiplication. So product of 2 and n, 2 multiplied by a number, 2 times a number, all are a way of saying 2 times that unknown number, which again, it could be any letter, but here we say n. And division, okay, less often you see division, but yeah, some things that might mean division are these. Again, different ways of saying the same thing. So the quotient means division, of z and 3, a number divided by 3, or the ratio of z and 3. Okay, is all a way of saying z over 3, or z divided by 3. So that's it, okay? And I'd say just before I jump into these on the bottom, the most common thing that is easy to mess up are these guys right here, okay? You see the words more than and less than, okay? And so what the mistake kids make here is when you say 8 more than a number, right? In English, we read left to right. And so when you see 8 more than a number, you think, oh yeah, that's 8 plus x. And with addition, that's technically still true, okay? Because addition's what's called commutative, meaning we can change the order without it affecting the answer. But subtraction is where that really makes a difference, because it would be wrong, 6 less than a number, it would be wrong to say 6 minus x. That is incorrect, okay? Because subtraction is not commutative, right? For example, 5 minus 2 is not the same as 2 minus 5, right? They're different, right? So when I have 6 less than a number, okay, you actually kind of go right to left, okay? So a number and then 6 less than that, right? So if I have $5 and I say, oh, my brother has $4 less than I do. So 4 less than my amount is not his amount minus 5, it would be my amount minus 4. So I don't know if that makes sense. But yeah, that's just something to remember, that when you see the words less than and more than, that's kind of a tricky one where you have to change the order, okay? So let's look at a couple of these and try to catch some of them, okay? So again, anytime I see a number, that's where an x goes, okay? And I actually have that very first one. Look at that. 7 less than a number, okay? So just some number. Again, it's unknown. I'm not told what the number is, but that's just going to be x. So 7 less than that number, I would not write 7 minus x, that's the common one, but x minus 7. Okay, that's how I would write that. And again, these are expressions. You're going to notice none of these have equal signs in them, okay, because expressions are just kind of phrases, right? You notice these aren't full sentences up here with a period at the end. They're just phrases. So in math, it's the same thing. It's just going to be just an expression with a few terms, okay? The total of 5 and c. Okay, now this one I don't have to change the order, but the total of 5 and c, again, it's helpful as you're learning this to have that, right, this bank with you here. So we see the total of x and 8. So when you see that word total, total means I'm adding things together. So total of 5 and c, so 5 plus c. Okay, is how I'd write that. 7 less than twice m. Ooh, okay, 2 different operations happening here, and they kind of sneak one in there. So I see the 7 less than, okay, but I also have this twice m, okay, twice m. Twice, again, means 2 times that amount, okay? So 2 times m, and you notice I'm going to do that first. Oftentimes with these, especially the more complex ones, right, it's different. It takes some getting used to. In English, we read left to right. In math, a lot of the time it helps to read right to left, okay, especially with ones like this. So 7 less than twice m. So I have twice m, but I want 7 less than that. So I do that amount minus 7. Okay, that's how I would write that. The sum of a number and 16. So the sum means addition. So the sum of a number and 16 would just be x plus 16. Okay. A number increased by 8 points. I don't know why it says points, but a number increased by 8. So again, that unknown number x increased by 8. So I'm going to plus 8 to that. Okay. Number 6, the quotient of w and 10. W, again, that unknown amount. But I'm dividing, okay? And here, again, quotient means division, but I'm dividing. It's going to be, you notice, anytime you see the words like sum and quotient, you're going to have an and separating the two things that you are dividing or adding or whatever. So that's what separates the two things. So the quotient of w and 10 is going to be w over 10 or w divided by 10. You could write the division sign too. Okay, 7, the difference of a number and 8. Okay, so the difference, same thing. That's one of those different math words. So again, and separates the two things that you are subtracting here. Difference means subtracting. So a number and 8, x minus 8. Okay, 12 more than a number. Okay, so again, more than. We said more than and less than are the ones where those should ring some alarm bells in your head, because we're going to change the order around. Okay, so 12 more than a number. So it means I have the number, and I'm going to plus 12 to that because I want 12 more than that number. Okay, So I plus 12 to that unknown number. Okay, now 9 through 14, we see it steps it up a notch. A lot going on. So 7 more than the quotient of a number and 2. Okay, so especially with these more complex ones, again, we read in English left to right, and then we're actually going to put it in order here, right to left. Okay, and so, but again, it kind of goes by phrases, so you don't start with 2 and then go from there. But I say that because 7 more than does not go first. You don't do 7 plus the quotient. The plus 7 is actually going to come at the end. But what comes first is this right here, kind of this phrase, the quotient of a number and 2. Okay, so I kind of ignore that 7 more than for now. And so I think, okay, the quotient of a number and 2, okay, what does that mean? That's division, again. So what am I dividing? A number, which is x, and 2, so x divided by 2. But again, now I bring in that 7 more than, okay, 7 more than that. So I have that quotient amount, but I want 7 more than that, so I plus 7 at the end. Okay, so that's that one. 10, 5 less than twice a number. Okay, same thing, 5 less than. So again, 5 less than kind of is going to come at the end. So I just want that twice a number first. So twice a number means 2 times that unknown amount, but then I want 5 less than that amount. Okay, so that's going to be minus 5 at the end. So 2x minus 5. Okay, 11, 1 less than the product of 4 and a number. Okay, again, I'm going to say that 1 less than for the end, but the product of 4 and a number comes first. So product means multiply. So product of 4 and a number would be 4 times that unknown number, x. But then 1 less than that means the minus 1 comes at the end. Okay, a few more. 6 less than 6 times a number. Okay, so similar. 6 times a number would just be 6 times the x, the unknown number. But then I want 6 less than that. So minus 6 happens at the end. Okay, I hope you're starting to see some patterns in here. Okay, 13, 7 more than twice a number is 1. Ooh, I lied. I said none of these would be equations. This one actually is. So, and I know that, and you notice, this is a full statement. Okay, it has a period at the end, and this word is 1 is going to imply that it's going to equal. Is a math word that implies equals 1. Okay, so I'm just going to leave that. I dealt with that. I'm going to leave that off for now. Okay, so I dealt with that is 1. So then this, but the left side of this equation is going to be similar to the ones above. Okay, so twice a number. Again, twice means double or 2 times that unknown number. So 2x. But I want 7 more than that, right? So 7 more than 2x would be 2x plus 7. And then is 1, I cross it out, but is 1 would be that equals 1. Okay, 14, last one. The product of 8 and the difference of n and 3. Wow. Okay, now the key here is going to be these words and, okay? And, because again, like I said, and separates what I am actually doing. So the product of 8, so product means multiply, of 8, so I'm multiplying 8 times, I'm doing 8 times what? I'm doing 8 times the difference of n and 3. So it's going to be 8 times this other operation, okay? So 8 times the difference of n and 3, okay? So it's actually going to be 8 times the difference of n and 3. So the difference of n and 3, difference means subtraction, so I'm subtracting n minus 3, okay? But that's still being multiplied by the 8, because it's the product of 8 times this difference, okay? So that's how that one works out. Okay. So there it is. Again, there's a back to this. I'll do that in a separate video because I think I'm out of time, but hope that makes sense. This is really tricky stuff. So good job.